Welcome back to everyone. My name is Shivam Agarwal and this is the second part of our project 5 called as Bank Customer Exit Prediction. So we have already looked at the data set. In this video, we'll start creating our project. This will be an artificial neural network based project in deep learning. We'll try to clean the data if required. Then we'll create the ANN. Then we'll train, test and predict the model. Then in the next video that is coming up, we'll deploy the model. Okay, so let us look at the dataset. I'm using Kaggle Community Platform for creation of this dataset. I'll mention the link to the dataset in the description box. You can see it over there. This is deep learning A to Z ANN dataset that is all about the bank exit prediction. Okay, so let us now create the project on Kaggle itself because it provides us with all the necessities, be it hardware or software. We don't need to have any GPU or high core RAM in our system. Whether it is an old PC or a new hardcore PC, you can create this project on Kaggle. Okay. Also, it provides you software like you don't have to install any repository or libraries in Python or Keras or anything like machine learning or deep learning. It is already installed in the Kaggle server. You can directly import them and use them. Right. So we'll start with the new notebook. Here you can see a new notebook option. We'll click on it and it will create a new notebook for us with the dataset. Okay. So it is creating the notebook for us. It has loaded the dataset and it has imported two libraries for us. Okay. Let us name this notebook as maybe bank exit. I'll name the project as bank exit. I'll mention the link for this notebook in the description also. You can look up to it. What I'll say is I'll recommend you to try the project on your own, seeing the video. If you are stuck at any point, you can always look up to the code that I have coded, right? But try to create the project on your own. So I will be using the accelerator GPU because this will be an artificial neural network. So we might require a neural network GPU. So I'll be using this GPU T4X2. You can also use this GPU P100 that is created by Tesla. However, GPU T4X2 is created by NVIDIA. Both of them have higher performance, very high performance. So I'm using this. Let us run the first cell. So it will start our session. We will get some amount of CPU, GPU and RAM along with the storage for this dataset. For now, let us import some libraries that we'll be using for creating this project. First of all, I will import matplotlib. Inside matplotlib, I'll import pyplot as plt. So our session is started. You can see we have a CPU, GPU, and we have RAM, 73 GB available. However, it will be reduced in a couple of minutes because we will not be using 73 GB of RAM. Next, we want to import cbond as SNS. Next, what we want to do is we want to import something for accuracy score. Like we were judging the accuracy of the models in the previous projects also. So if we have to judge the accuracy of our model that is predicting, we'll have to import something called as accuracy score. Okay, so we'll be doing that also. Before that, let us import scaling and encoding characters from sklearn. You already know that in pre-processing, we have something called as label encoder and we have something called as standard scaler, right? So these are the two things present in inside pre-processing. Next one we want is train test split. So I'll say sklearn dot this time model selection. Inside model selection we have to import train test split. Okay, so we have our encoder, scaler and train test split functions. Next, what we want to do is we want to import some libraries related to neural networks. Before that, I'll just say matplotlib inline. It's inline. Let us execute this cell first. So it's saying from sklearn we have to specify from sklearn and it's successfully executed. Next, what we want to import is some libraries related to the neural networks. So for neural network, the most important library in Python is Keras. It is built on TensorFlow, so we don't need to have every feature of TensorFlow. We can directly use Keras. So I'll say import Keras. Or K will be small. Yeah. So import Keras. Next we want to do is import a model inside Keras. So I'll say from keras.models, I have to import a model called the sequential model. We'll be creating sequential model. So it will create a neural network for us. So I'll say from keras.models import sequential. Okay. Nextly, I want to include some layers for this neural network. Whenever we create a neural network, we have to create some layers. There is an input layer, there's an output layer, and there are many hidden layers. Okay. So that is how we'll create the neural network. For that, I will import some of the layers. So I'll say as from keras.layers. Inside layers, we have something called as dense layer. So we have dense layer, we have a dropout layer that we'll be using, and we have a couple more layers that I will be showing you. The first is ELU, next one is PRELU. It is written like this. Okay, so these are the layers that we are going to use in our model. Okay, so we have our layers right here. Next, what we want to do is we want to import something called as accuracy score. So I'll say from sklearn, this time from sklearn.metrics, I will import accuracy score, accuracy underscore score. Okay, so this will help us to judge the accuracy of the model. Okay, so that is how we'll do it. Let us import one more layer called as leaky relu. There is something called as leaky relu, and it is written as LU. And next we want something called as prelu. However, we will not be using these three layers, ELU, leaky relu, and prelu, but I'm just showing you that these are also the layers that you can use in your neural network. Okay, we'll be using dense and dropout layer for now. Let us execute this cell. Yeah, it is done. So nextly we'll move on towards our data set. Okay, so this data set is right present over here, churn modeling.csv. We'll import it. The data set that I'm using will be created inside a variable called as df. So I'll say df equals pandas dot read underscore csv function, and I will say that inside this I want a path. The path for this dataset is available right over here. Inside the input section, you can see this churn modeling.csv file, and right beside it, you see this copy file path option. If you click it over here, the file path will be copied. You'll come over here and you can paste the file path. Okay, this will import our dataset. If you want to see the dataset, you can do df.head. If you don't pass any parameter to head, it will automatically give you 5 rows, first 5 rows. Okay, if you pass any parameter, it will give that number of rows. So I'll require just 5 rows for now. Yeah, so this is our data set. We have some row number, customer ID, surname, and we have some features that we want to extract. And finally, we have our exited column, that is our output column. Okay, so our data set is looking quite good. Let's move on to next section. Let's see if there are any null values present over here, right? So how to do it? We'll say data frame, that is our data frame, dot isNull function. IsNull function will return if there is any null value inside our dataset. And what we want to do is we want to get the sum of it, sum of all the values that are present, okay, that are not present, that are unavailable. Okay, so if we try to execute this cell, I will get each of the column, and you can see there is a 0 value for all the columns. So there is no any column that contains any null value. We have all the values inside the dataset. So the dataset is quite clean. We can move on with label encoding. Why label encoding? You can see over here, row number is not useful to us inside our features. Customer ID will also be not useful to us because this is some random ID. Surname will also be not useful to our data. Okay, because the name of a person doesn't determine that whether he or she will be stay with the bank or not. Okay, we'll start with credit score. It is already encoded. Geography is not encoded. So we'll try to name these France, Spain and Germany as 0, 1 and 2 using label encoder. Next, we want to classify gender also. 0 will be allotted to female and 1 will be allotted to male because female is present before. Next, we have some integer values right over here. In the last, we can see that all are integer values other than geography and gender. So we'll encode these two values using label encoder. So for that, we have to initialize the label encoder. How to do that? We'll create a variable L equals label encoder that we have already included as a library above. You have seen. So when I say label encoder, next what we want to do is we have to encode these two values, geography and gender. So I'll just copy geography. I will say df of geography equals L dot, L is our label encoder variable, fit underscore transform. This function will encode these values. Okay, so I'll say what it has to encode, df of geography. I'll again write this much. I'll just copy this thing and do the same for gender. I have something called as gender and I have to fit underscore transform gender so that I get 0 for male and 1 for 0 for female will be allotted and 1 for male will be allotted. Similarly for geography, if you see, France will be allotted as 0, Spain will be allotted as 1, while Germany will be allotted as 2. Okay, this is how the label encoding will work. So if we run this cell, what we'll get is our new data set. Now what we have to do is we have to divide our data set into X and Y. You might have already guessed that we don't require the first 3 columns in our X dataset because these 3 do not have any features related to them. We'll start from credit score, move on until exited column. Okay, so that are the columns that we require. There are 10 columns, I think. Yeah, and the last column is exited. That is our Y column. So what will I say is I have to determine X values, and I will say df dot drop because we don't need certain columns, so we'll drop them. And inside this, I will say I have to supply a list of all the columns that I have to drop. The first one will be the row number. The next one will be so I have my data set right here. I think the data set was okay. I think the data set was deleted right here. I'll say just once again pd.read underscore csv. I think the dataset column was deleted somehow because I'm not seeing it over here. I'll just copy the path once again. Once again run this cell with df.head. So our everything will be reset. Yeah, again this null column. Then we have to do is label encode. Then we have to check. Okay. So nextly what we want to drop is customer ID. So we'll say drop customer ID as well. We don't need customer ID. Then what we want to drop again is surname. I'll copy it. I don't need surname. Next what we want, we don't want our last column exited also in our X values. So we'll drop that also in our X value. So we'll drop the exited also. And we have to specify the axis along which these columns will be dropped with. So the axis will be vertical and vertical is specified by 1. Okay. So along the axis of columns, I have to drop all these things and store the rest of the data inside X. Okay, that is the meaning of this line. Nextly, in our Y, what I want is just one column, that is exited column. So I'll say df of exited. Right. So this will divide our data into X and Y. That is executed. It's quite done right now. Next, what we want to do is we have to split our data into training and testing. So we want to do train test split. Okay, so I'm marking it down right here. You can use markdown cells on Kaggle to mark something down. So what we are doing right now is train test split. So we'll use train test split function that will return 4 values. The first value will be x train value, second value will be x test value, third one will be y train value, and the last one will be y test value. Right. So the sequence of all of this matters a lot, because this is how the function train test split is going to return the values. Okay, so we'll call the function train test split and we'll supply some values to it. What are the values supplied? We first have to supply the x value, then we have to supply the y value, then we have to supply the test size. Remember, the test size has to be smaller than the training size. Test size generally is of length maybe 10 to 30%. For general, I will say that test size equals 20%. So I'll say 0.2, that will mean the 20%. The last parameter will be random state. You might have already known that random state is something that will allow us to randomly distribute the data between training and testing. If we don't include random state, it might be possible that a similar data is placed into training and some similar data is placed into testing without any normal distribution. So to encode for normal distribution or random distribution, we allow this parameter here, random state as 42, or you can experiment with this value if you want some distribution also. Okay. So that is it for train test splitting. I will execute this cell. Yeah, so we have some value over here for training and testing. Next, what we want to do is we want to check whether these values are scaled or not. So if you see over here, the credit score values are probably between 500 to 800 or 900, like that, right? So, and this geography and gender will be integers 0, 1, 2 maximum, and gender will be 0, 1. Right, the age will be a an integer below 100, tenure will be maybe below 10, balance will be ranging from 0 to hundreds of thousands. Right, all of these values are scaled on different scales. So to not to do, what we don't want to do is we don't want to favor one parameter over the other. Okay, if the scaling of all of these columns is different, then what can happen is our model can favor one of the features over other. So we have to scale them down on single scale. So we'll do this by using standard scaler. We have to initialize it. I'll say standard scaler. Nextly, what I want to do is I want to scale all the x values, because y is just one column, we don't have to scale it. In x we have a lot of columns, we have to scale everything down to one scale. So I'll say x train equals sc dot fit underscore transform. Remember, we were doing the same function inside label encoding also. The same function is overwritten in the standard scaler also. Okay, this is an example of polymorphism. If you want to know more about object oriented programming in Python, you can check our playlist. It is available on our channel also. Okay, continuing with this, we'll say fit underscore transform of x train. Okay, similarly for x test, I will write x test equal to sc dot fit underscore transform of x test. So this will transform all the values on a single scale for train and test both. So these values are executed. We have our x train and x test ready. Next, what we want to do is create our neural network. Yeah, so that is what we will create. We have already read the data, we have marked it down, and we have splitted the data into training and testing. What we want to do now is creating the neural network, or I should say artificial neural network. Neural networks can be of three types: artificial neural network, convolutional neural network, and recurrent neural network. In the coming two projects, we'll be seeing some videos on some projects on convolutional neural network, where we'll be dealing with images also. But for now, this is artificial neural network, also called as ANN. Okay, so let us try to build it. The first step that a neural network has to be built is we have to deploy a sequential model. We have to build a sequential model. So what we want to do is we want to create a variable. For example, in this we have to classify. So I'll say that CLF is my variable for model equals sequential. This particular statement will be common for all the neural networks that you will be creating. The sequential model has to be initialized first, and that is how we start the creation of neural network. Okay, so I have initialized the neural network with this. You might want to use a GPU over here because we are dealing with neural networks, and we must use GPU for speeding up the process. Ignore all these warnings because we haven't supplied any parameter to sequential. That is why it is giving me so much warning. However, you can ignore these. Okay, we'll continue with it. What we want to do is we have initialized the sequential model. Now we want to create the neural network. To create a neural network, we have to create some layers. So there will be an input layer of the neural network. There will be an output layer. And in between these two, we will have some hidden layers. Those hidden layers can vary. If you want to vary that, that will not be an issue if you want to vary those hidden layers. But for general, I'll be using a simpler neural network because processing a neural network can take a lot of time. And for the sake of the video, I'll say that if you want to experiment with the neural networks, you can go on Kaggle and use this GPU and just experiment with the neural networks. Okay, so we'll try to create now some layers. I'll say clf dot add. This add function is used to add a layer to the neural network. So we'll add our first layer. The first layer has to be a dense layer because it will take a lot of inputs and it will provide any number of outputs. Okay, you can specify how many number of outputs you can have in the inner layers. However, in the last layer, that is our output layer, there has to be just one output. Okay, because it is classification. So I'll add a dense layer. This is how you add dense layer. Inside this dense layer, you have to specify what kind of dense layer it is. Okay, what are the parameters for this dense layer? So I have to specify something called as input dimensions. This input dimension means how many inputs is this model expecting from the user. So if we see over here in our data, we have not used anything before credit score. Starting from credit score, we have how many values? This credit score, second geography, third gender, fourth age, fifth is tenure, sixth is balance, seventh is products, eighth is card, ninth is active member, and 10th is salary. So these are the 10 features that our model is requesting for. Okay, so I will say that input dimension for our model is 10. Okay, nextly, the next one will be units. The units will specify how many output will this layer will have. So there are some inputs towards the layer, and this layer will process those. This layer will process some of the outputs also. Okay, so how many outputs do I require? I'll say just 10 outputs, right? So there are 10 inputs and I'll require 10 outputs. Okay, next parameter will be kernel initializer. Remember, the initializer will have a Z in it. Okay, so the kernel initializer specifies what kind of activation or uniform do you want. Okay, so you want something called as either a he uniform or something called as activation. So that will be specified inside this kernel initializer. Okay, this is one of the most important steps in adding a layer because this initializer will determine how your model will work as an accuracy. Okay, so I'll say that because we are dealing with a lot of features and we require just one output later on, I'll say that he uniform will work best for now. You can read about these he uniform and other features on the link that I've mentioned in the description box. I will specify the documentation for Keras. You can read them all over here. Okay, these are available on the internet also. If you write a kernel initializer for Keras, you can get the documentation also. Okay, so let us proceed for now. Lastly, what I require is the activation function. So the activation function can be either sigmoid, relu, prelu, or something like that. Okay. For the inner layers, I always use something called as relu. Okay. And for the outer layers, that is output layer, I will use something called as softmax or sigmoid. Okay, based on what I have created in the inner layers. So for now, I'll use the relu activation function for the first layer. That is it for the first layer. Let us add another layer. Okay, so now that we have added a dense layer, what our model will do is it will try to take 10 inputs and it will process them with 10 outputs. It might be possible that after the first processing stage, there are certain features that are not to be considered anymore. It might be possible that model has accurately determined already that there are some features that have to be dropped. So we'll have to add a dropout layer to eliminate those features. Okay, so I'll say clf.add and I'll say dropout. Okay, we have to specify inside it just one parameter that is compulsory. That is what percentage of features we are expecting to be dropped out. So I'm expecting 30% of the features are to be dropped out after first processing stage because this is a relatively smaller data set. Okay, so I'll say 0.3 and that will drop the 30% of the useless features. Right. Nextly, let us add some more layers. I will say again a dense layer, so I will just copy this first layer. I will have to make changes to it, so don't just copy and paste. I'll have to make some changes to this layer because this is not the first layer anymore. So I don't require this input dimension right now because input dimension is required just for the first layer. So I will eliminate this input dimension feature. Next, what I use is units equals 10. Yeah, I will not change it. Then kernel initializer is also he uniform. I will not change it. Then activation is relu. Yeah, it is fine. I will not change anything else. What I want to do is I want to drop some more features that are useless to us. So I'll add a dropout layer again. For the sake, I will add another dense layer so that it processes our result better. So I'll add the same dense layer that I used above. Again, once again, I will use 10 parameters. The kernel initializer still is uniform and I'm using relu for this. Okay. Lastly, what I want to do is I want to drop out once again. So I'll say this dropout. And finally, I have to get the output. To get the output, I will create a layer, dense layer, but this time the output layer is somewhat different from the inner layers. So I will copy, but I will change the values. So the units is 10 in the inner layers, but in the last I just want either the exited is 0 or 1. So there are just two values, 0 or 1. So I want just one value. Okay, either it is 0 or 1. So I'll say unit equal to 1. Okay, the kernel initializer is not he uniform because what we want is we don't want a large number of values. He uniform is used to deal with large number of values. So we don't want to deal with large number of values here. So I will use something called as Glorot uniform. Okay, you can read about this stuff or you can let us know. We'll try to create some videos to know to tell you what are these kernel initializers, what are these activation functions, what are these layers all about, how they work. But for now, let us see how to create this project first. This kernel initializer, for the last layer, I'll be using Glorot uniform, and the activation that I told you before also, relu, is used to give a lot number of outputs that we were giving 10, 10, 10. Now we want just one output, so we'll use something called as sigmoid. Okay, you can also use softmax, but generally softmax layer or activation is used where you have to predict the probability. Okay, if we were dealing with probability of something, we must have used softmax here in activation in the final layer. But as we are not dealing with probability, we are dealing with discrete values 0 or 1. We are dealing with sigmoid. You can see over internet that sigmoid is a function that has two ranges of values, either it is 0 and 1. It quickly escalates from 0 to 1 in a fashion. Okay, so that is how you create a neural network. You have added a dense layer, then dropout, then dense, then dropout, then dense and dropout, and finally a output dense layer. So you have an input layer. These two are called the hidden layers, these two dense layers. Dropout is not a hidden layer. It is just present just to drop the useless features. Okay, so you'll say that yeah, my neural network has 4 layers right now, 4 important layers that are dense. Okay, so if you execute it right now, you will create the network. But before executing it, let me just compile the model also. After creation of neural network, what you want to do is you want to compile all these things into a signal unit. Okay, so that your network works as a whole. So what we want to do is we want to compile the model. So I'll say clf.compile. I have to specify an optimizer over here. So now I must tell you what is an optimizer. So optimizer is something that will define the accuracy of this whole neural network as a whole. Okay, so optimizer can be Adamax or something like that. For now, I will use Adamax optimizer. If you want to know more about this optimizer, I will put the link to all of these things in the description box. You can read over here. The official documentation of Keras is very easy to understand. You will see how optimizers, these activation functions or kernel initializers work. Okay. If you want to know more about them, you can let us know. We'll try to create some videos on that also. Next, what we want to specify is loss. So in the previous projects also, you must have noted that while you were training your model, you were getting something called as a loss and accuracy. So accuracy was what we were concerned with right then, but from now on we will be concerned with loss also. Okay, so loss has to be minimized. You already can guess that loss has to be minimized. It has to be as low as possible, and accuracy has to be maximized. Okay, so as we are dealing with two values in our dataset, in our output layer, that is 0 and 1, what I will do is I will say that loss will be binary in nature. So for binary nature loss, we have something called as binary cross entropy. Okay, we have something called as binary cross entropy as our loss. It is written like binary underscore cross entropy. Next, we have to specify our metrics. The metrics, you would have already guessed what I am always concerned with is accuracy. The metrics that we are concerned with is accuracy right now. Okay, so that is how you will compile the model. We have an optimizer called as Adamax. We have a loss for binary cross entropy, and we have metrics as accuracy. Let us run this cell and see how we have created our neural network. It is run quite quickly. So I can say that, yeah, my neural network is created. Now it is time to train our neural network, which will take a lot of time if I'm not using the GPU. Even if I'm using a GPU, it will take some time. So be patient and join me. I will say that, yeah, it will be called model. And next, what I want to do is we want to fit it. So clf.fit, like you train the machine learning models, you also train the deep learning model. There's no difference. What I want to supply is xtrain, ytrain. Another parameter that I have to specify while creating artificial neural network model is validation split. What is this validation split? So this validation split will divide the xtrain value into the two parts, and it will try to automatically train on the first part, and it will test the accuracy on the second part. It will keep on doing this in the random nature so that our metrics equal to accuracy is met. Okay, to increase the accuracy, it will continuously divide the data into training, testing, and it will try to train the value on some other values, then it will test, then it will train the values on some other values, and then it will test. So it will work like that. So validation split I will supply as just 20%. I don't want to specify a larger value for validation split. And next, what we want to do is epochs. Remember how a human brain thinks? You know that whenever we see a new thing, we tend to think yet what it is. Okay, some people tell us that that is a car. So the first time you see a car, you don't know that is a car. If the second time somebody tells you that is a car, you try to remember it. But when you come across a car again and again, you tend to learn it. Okay, so we have to apply this kind of learning to neural networks also. So we have to train the neural network multiple times. So this epochs tells us how many times we have to train our neural network. So I'll say that I will train the neural network 100 times for now. I think that 100 would not be too long, but I will say that, yeah, below 100 would not give us a nice accuracy. So I'll say at least 100 would be good. I'm not sure if 100 would also give me some nice accuracy. I would automatically train it to 300 to 400 epochs in a normal state. But for this video, I'll train it just 100 times to see what accuracy I'm getting. Next will be batch size. This is an optional parameter, and I'll say 10. So batch size is directly related to validation split. Validation split will split the data into 20% and 80%, and batch size will be 10. Okay, in that. Let us fit the model and wait for it to complete. So one by one, all the epochs will be performed. Let us start with it. So it is first epoch that is running right now. 640 features are there. Second epoch done, third epoch done. It will take quite some time. Right now it is on sixth epoch. We have 100 epochs in total. If you see right over here, you can see something called as loss. This loss is 0.66 in the first one, then 0.58, then 0.54. So that is, you can see our loss is decreasing one bit by bit. Okay, that is what we were doing right here. We have binary cross entropy loss. Our mission is to reduce the loss and increase the accuracy. You can see the accuracy is increasing as well. 66, then 75, then 78, then 78, then it approaches 79 in the sixth epoch. Like that it is working. So you are reducing the loss of the data and you are increasing the accuracy of prediction. Okay, let us see how much is done. It is almost 33% now. It will take some time based on the running speed of GPU. However, if you were not using a GPU, it will take a lot of time to create this kind of neural network or train this kind of neural network. Especially in the case of images, it will take a lot of time. This is textual data, so it is working quite fast. Each epoch is working in just like 2 or 3 seconds. So it's not taking much. I'm sure it will be done in a couple of minutes more. After that, we will try to test our model using prediction, and finally we'll see how this loss and accuracy are plotted against each other. Okay, so how this loss was minimizing and this accuracy was increasing. We'll see and visualize, try to visualize that as well. Okay, uh, let us see if it is done. It's on 61, 62 right now. So until it is completed, let us try to write some more code. We have to predict something out of this model. Okay, so how do we predict it? We use yp equals, our model is clf dot predict. We have to use predict and we'll supply the x-test values. Right. Next, what we can use is we can use confusion matrix for judging the accuracy, or we have already included accuracy score. We can also use it. So we'll use accuracy score for now. The score equals accuracy score. This accuracy score is used to determine the accuracy or the conditional accuracy of this model. Okay, so I'll supply the yp and ytest. Remember, yp is predicted values for x-test and ytest are the original values. We are comparing predicted to the original values. Okay, in the score. Next, what we want to do is we want to see what is the score. I'll say score. Let's see if it is completed. Yeah, so it is already completed. We can run the predicted values now. We have predicted values in yp. We have our score here. So it is saying that it is a mix of different values. What you have to supply inside it is yp and ytest. Okay, so this yp is something that is telling me the probability. So I have to categorize it into 0 and 1. This is just giving me the probability, that is a number lying between 0 to 1. So I have to categorize into 0 and 1. So if something is above 0.5 or 50%, then I'll say that yeah, it is 1. And if the number is below 0.5, I will say that it is 0. Okay, so I'll categorize it with a simple formula. Yp equals yp greater than 0.5. If the yp value will be greater than 0.5, it will store 1. It is less than or equal to 0.5, it will store 0. Okay, that is how it will work. Let us try to execute it. Next, we'll try to predict the score. In the score, I must have got the accuracy. Okay, so this is the accuracy predicted by the artificial neural network. 83.55% is quite nice for 100 epochs. I'll give you an assignment that run it for another 100 epochs and tell me what is the accuracy for 200 epochs. Okay. Let us now proceed with another thing. Remember that in the first part of this video, I told you that we'll deploy this model. To deploy this model, we have to save it right here because the deployment won't be done on Kaggle. So to save any model, whether it is deep learning or machine learning, you will use a simple command called as save model. Okay. So I'll say clf dot save, and inside it you will write the name of the file. I'll say that bank exit is the name. Okay, so bank exit, and the extension of it would be h5. Okay, this is an h file, or you can say har file, and this is how you will save a model. Okay, bank exit will be our model which is present inside clf. It will be saved in the output directory if you run this cell. So now inside the output directory, if you expand it, you can see in a couple of minutes that our bank exit.h5 file is ready for downloading. Okay, so you must download it from right here. Okay, it will be used for deployment of our model. Okay, let us close it for now. Let us proceed further with prediction of our model. Remember how we predicted the values? We have to supply a double list inside it. We'll say that yeah, a will be some list and we'll predict the value. Okay, how will predict? We say clf.predict and we'll supply a inside it. So now we want some values over here. I'll just use df.head to get I've used df.head to get the type of values that we require. Okay, inside A, what we require first is credit score. Let us say the credit score of a person is 720. Next, geographical location. Remember that France is 0, Spain is 1, and Germany is 2. So I'll say the person lives in Germany. Next, the gender is 0 for female and 1 for male. I'll say 0. Age will be 32 in my case. Then tenure is 1 probably. Balance is 0. Next, what we want is number of products. Let it be 1. Hash card 0. Active 0. And finally, we have estimated salary, I think. Yeah, estimated salary is probably 20,000. Yeah, so for 20,000, let us predict what is the value, whether he will stay or exit. Okay, so it is saying this person with these kind of credentials will probably exit the bank in a few days. Okay, if I want to increase the salary a little bit, I'm sure that it might change. It's still saying that the person will exit. So a single parameter is not determining. That is a good sign of this dataset. Okay, if you want to play with these values, you can always do it. If you want to change a value a little bit, you can say that the values might change for all. Okay, yeah, so you can play with these values. You have to specify the credit score, geography, gender, all of that in a selected sequence, and you can vary all of them and check whether they are exiting or not. Okay, so this kind of person will not exit. It is showing me 0. Next, what we want to do is we want to check of this accuracy and loss. So the last thing that we are going to do will be deployment. But before deployment, you must know that you have created an artificial neural network, and in an artificial neural network, the most important things are loss and accuracy. So you must know that loss should always decrease and accuracy should always increase. Okay, so to visualize this, I will just plot these two things. I will quickly say that plt.figure, and I'll supply the figure size. There will be no underscore, I think. Yeah, figure size would be let us say 15 and 10, 15 rows and 10 columns. That will be enough. And nextly, what I want to do is I want to plot the graph. I will say model.history because every plotting is stored in the history of the model. Okay, that is why we created the model variable over here, the model.history, and I will say that I have to plot the loss. Okay, so I'll plot the loss. Next, I want to plot the validation loss as well. So the if you don't specify what kind of loss it is, it will automatically take the training loss, and if you specify the validation loss, if it will take the validation loss. Remember that we were dealing with validation split. This is something validation loss. Okay. Next, we want the labels. Let us just say legend. The first will be train and the second would be test. Yeah, and the location I want is upper left. Remember, there will be a space between upper and left while determining the location, and I'll say plt.show for showing it. If I execute it right now, you will see the train test graph. So you can see for our loss, we have a continuous decrease in the training loss as well and the test validation loss as well. Okay, so our model is working quite nicely. You can see a continuous loss decrease. Okay, similarly, if you want to plot the same thing for accuracy, just copy and paste it, and I'll say that accuracy and validation accuracy. Right, and I will say that show me the epoch, show me the plot, and yeah, you can see the validation accuracy is increasing bit by bit, and similarly the training accuracy is also increasing. Okay, so that is how you have plotted accuracy and loss with validation. We have already saved our model. We'll be using this h5 file to deploy our model in the next video. So remember to watch that video also, because using that deployment steps, using those easy deployment steps, you can deploy any model that you have created till now using Streamlit, that is a Python framework. So let's meet in the second or third video in the deployment part. Okay, thank you.